Hi everyone, welcome to this lecture. So in this lecture, we are going to learn about another optimization technique, which is known as adaptive movement estimation optimization. But it is famous for the name of Adam optimization. Let's see what we can learn in Adam optimization and how Adam optimizer works. So Adam optimizer is a very smart optimizer. It combines the feature of the momentum and RMS prop. If you remember, this is the equation of the momentum which we added to our stochastic gradient descent. And after adding this term to the weight updation of a stochastic gradient, it becomes stochastic gradient descent with momentum. So Adam used the features of this momentum equation and it used the feature from this RMS prop equation. So here we can see that we have a gradient term, and here in RMS prop, we can see we have a square of gradient term. So this is the current value of the weighted average, and this is the past value of the weighted average. So here beta 1 is the parameter which controls the process of weighted average in the first order derivative or in the momentum term. But in RMS prop, the parameter which controls the weighted average process, it is denoted by beta 2 so that we can make difference between beta 1 and beta 2. Here we have the square of the gradient term. So what Adam optimizer does is combine the properties of the momentum term and RMS term. So if we combine both these equations and solve, we will get this equation. We can see that these are the updated equation of the parameters. So theta is the parameter, which is basically the weight and the bias of a neural network. So this is the new value of the parameter and this is the old value of the parameter. The new value is basically the updated value of the parameter, and you can see that it is obtained by subtracting this whole term from the old value of the parameter. If you see here, S is the parameter which comes from RMS prop equation. V is the parameter which comes from the momentum equation. And eta, this term is a learning rate. And this epsilon is a very small value and it is used to avoid zero in the denominator. Suppose this term come out to be zero. In that case, we cannot divide anything by zero because we will get the infinite term. So in order to avoid a zero in the denominator, we will add a very small term, which is denoted by epsilon here. So if you see this equation is the combination of the features present in the momentum equation and in RMS prop equation. And these are the parameters which are coming from these two equations. So Adam optimizer is the optimizer which combines the properties or the feature of momentum and RMS prop. Now, the values used for different parameter in Adam optimizers are these values. We usually use 0.01 for the learning rate. We use 0.9 for the beta 1. So beta 1 is the parameter which controls the weighted average process in momentum term. And beta 2, we usually use 0.99. Beta 2 is the parameter which is used in RMS prop. And this epsilon is a very small value which we use in the denominator in order to avoid the division by zero. So these are the recommended values of the parameters used in Adam optimizer. So I hope you understood the process of Adam optimizer. It is just the combination of momentum term and RMS prop. And the purpose is same, that is to update the weights smoothly. So I hope you understood the basic mechanism or a working principle of Adam optimizer. Thanks for listening this lecture and I will see you in the next lecture.